So the first thing we're going to talk about is how to find an inverse. So when you're finding the inverse, you switch the x and the y, and then you solve for y. So when you're finding the inverse, you switch x and y. This is like y, so we're going to switch it. We're going to call it x equals the cube root of y minus 4 plus 5. So when you try to solve for y, we need to isolate the y, so we're going to move the 5 over. And then to get rid of the cube root, you will cube both sides, do the third power of each. And that cancels out the cube root. So we have x minus 5 to the third equals y minus 4, and the cube root's canceled out. So to finish it off and get y by itself, all you do is add the 4. So add 4 over, and you get y equals x minus 5 in parentheses to the third power, and then we added the 4 over, so plus 4. Now, if you, to be official, you don't want to write y equals, you want to write f inverse of x. Just put the notation that they gave you in the problem. So same thing for number 2 here. Finding the inverse, this is y, switch x and y. So this becomes x equals square root y plus 3 minus 1. Move the 1 over first to isolate. So that's x plus 1. Equals the square root y plus 3. Then to get rid of the square root, since it's a square root, we're going to square both sides. So that cancels out. So you have x plus 1 squared equals y plus 3. And we want to get rid of the, get y by itself, so minus 3. You get y's by itself now. And it's x plus 1 squared minus 3. And then, like I said before, it's officially it's not y equals, it's supposed to be f inverse of x equals. When you're solving these equations, when they have two different bases, you want to make them have the same base, so you can just cancel the base. So this is 3 to a power, 3 to the 2x. We want the other side to also be 3 to a power. 27 is 3 cubed, so you just replace it with 3 to the third instead of the 27. And then it's x plus 2. When you have a power to a power, you distribute, you multiply those exponents. 3x plus 6 equals 3, just 3 to the 3x plus 6, equals 3 to the 2x. Then, since they both have that base of 3, you can cancel them out. As long as it's 3 to a power equals 3 to a power, you cancel them out. So it's 2x equals 3x plus 6. Get your x's together so you can solve. So minus 3x over. Negative x equals 6, which means x equals negative 6. Same process for this next question. You want them to have the same base. They're both powers of 5. This is 5 squared. So it's 5 squared to the x minus 3. And then 125 is 5 to the third to the 4x. You're multiplying powers. Power to a power, you multiply. So this is 5 to the 2x minus 6. Distribute that. Equals 5. 3 times 4x is 12x. Then you can cancel the bases because they're the same. Cancel the 5s. 2x minus 6 equals 12x. Get your x's together so you can solve. So minus 2x. And then finish it off. We're going to divide by 10. Since we got negative 6 over 10, reduce that. Negative 3/5. Final answer. You just got to reduce it. So we'll skip a few problems. These are the same. Move on to number 9. So it's really 5 separate equations. You got to work them all out and see if they are the same. It's kind of tricky. So we'll start with number 1 here. Just like we did a minute ago, we're going to make that be 5 squared to the x plus 2 equals 5 to the 3x minus 2. And then we can do more with that in a second, but at least do the first step with all of these. For number 2, you're trying to make them be the same bases. So make them all be base 2, because 8 is 2 to the third to the power of x. And then 4 is 2 squared to the power of 3x plus 4. So if we go one step further with each of these, this would be 5 to the 2x plus 4 equals 5 to the 3x minus 2. This one is 2 to the 3x equals 2 to the 6x when you distribute, plus 8. The next one, 2 is already base 2, so that's good. 4, make that be 2 squared. And then you can distribute that. Distribute the 2, so that becomes, the left side doesn't change. The right side is 2 to the 6x minus 4. The fourth one, we can make those both be powers of 2. That's 2 cubed. 2 cubed is 8, so that's 2 cubed to the 2x. And then 32 is 2 to the 5th power to the x minus 2. So simplify those out. 6x. And then distribute that out. You get 2 to the 5x minus 2. No, 5x minus 10. You got to distribute it. And then the very last one, 16, that's 2 to the 4th. To the x plus 2 equals 4, which is 2 squared to the 3x minus 2. And distribute those out, and you get 2 to the 4x plus 8 equals 2 to the 6x minus 4. So now that you've worked all these out, it's looking for equivalent solutions. None of these are exactly the same yet, so we can't tell. We have to actually get these solutions. You got to solve each of them for x. So from equation 1 right here, the very top one, you end up, you can cancel out those 5s. From number 1, you get 2x plus 4 equals 3x minus 2. Get your x's together and solve it out. So subtract your 2x over, add your 2 to the other side, you get 6 equals x. From number 2, this equation, you can cancel out your bases. You get 3x equals 6x plus 8. Cancel out the 2's. So move the 6x over, you get negative 3x equals 8. And divide by negative 3, you get negative 8 over 3. Equation 3. This one right here. Cancel out your bases, you get 5x plus 2 equals 6x minus 4. Get your x's together, so minus 5x. And then we're going to add the 4 to the other side. Get 6 equals x. And another one, number 4. You keep the 6x equals 5x minus 10. Cancel the bases. Solve that out, so minus 5x. You get x equals negative 10. And then our last one, equation 5. Cancel out your bases, you get 4x plus 8 equals 6x minus 4. Hold on. Get your x's together, so minus 4x. Then we'll add the 4 to the other side. You get 12 equals 2x. X equals 6. So, x equals 6 3 different times. 1, 3, and 5. All right, so for this, write the equivalent form. So this is really just kind of doing change of base first. Since the 4 is the number that's already written a little bit below, that's your reminder that it goes to the bottom. Log base 4 on the bottom, log base, or not log base, log of 4 on the bottom, log of 7 on the top. 7 on the top, 4 on the bottom. That's change of base formula. The number that looks like it's lower down goes to the bottom. The base goes to the bottom. Then the other thing you can do is take it equal to x, and we're going to change it. Logs ask what's the exponent. Logs say 4 to what exponent is going to equal that 7. It's equation 3. That's the definition of a log. If you write it out equals x, you can then do that trick with the drawing the fish too. It goes through the 4 first, then the x, and then comes back to the 7. That's how you write your equation. Kind of the same question going on here. The base is 2, so it will be log base 2 of x equals 4. If you check that with the fish thing, goes through the 2, then the 4, 2 to the 4th equals x. That's true. That is what the question's asking. Then, this one's wrong because that's written backwards. You could change this. Since the 2 is the base, it goes to the base. You could do a log 2 on the bottom because 2 is the base. And there'll be log x on top. Those are equivalent. When you're solving out logs, you're going to convert them to an exponent. So you're doing the fish thing again. Through the 3, then the 1, then back to the x minus 2. Through the 3, then the 1, then the x minus 2. When you convert it to an exponential. Once you have it converted, it's just an algebra 1 equation. 3 to the first power is 3. Equals x minus 2. Solve it out. We're going to add 2 to both sides. You get x equals 5. Same thing for number 17 here. You go through the base first. 7 to the exponent's negative 3 equals x. X is already by itself, so we just need to do 7 to the negative third. 7 to the third power is 7 to the third is 343. So since it's a negative exponent, it becomes a fraction 1 over 343. Same idea here, but since it's natural log in e, you just have to remember e is nothing but a number. It's about 2.71828, 1828. So about 2.7. So the base of a natural log is base e. So if you were to rewrite this, you would do e to the 0 equals 2x plus 4. Any number to the 0 power is going to equal 1, even if it's a weird number like e. Anything to the 0 power is 1. Equals 2x plus 4. Finish it off, subtract the 4, you get negative 3. And then you divide by 2. X equals negative 3 over 2. You can do the same thing with number 23, but backwards. We're changing that to a log because the variable is in the exponent. So we're doing log base e, which is called natural log. It's got a special name, natural log. The exponent goes by itself, and then the 1 goes right there. Natural log of 1, anytime it's log 1, the answer is 0, because it's saying what power gives you an answer of 1. Log asks what power. So what power gives you an answer of 1? The power would be 0. So 0 equals 4x minus 3. Add the 3. 3 equals 4x. Divide by 4. X equals 3/4. Now, solving these out, very similar to what we were doing. When it's an e, you have to log to get the exponent down. So you turn it to natural log. And then you just flip the exponent with the equals. That's what log does. It solves for the exponent. Logs ask what's the exponent. So again, just like the last problem we did, natural log 1, anytime there's a 1 next to your log, the answer is 0. Equals 3x plus 2. So you subtract the 2, divide by 3, x equals negative 2 over 3. This problem goes back to the ones we did before, where you have to make them be the same base. So 4, we can make 64 be a power of 4. You can also make them all be 2s, but 64 is 4 to the third. So it's a little bit easier that way. So you got power to a power, you got to multiply. That's 6x equals 4 to the 3 minus x. The bases are the same, so you cancel them out, and you get 6x equals 3 minus x. You're going to add x to both sides to get your x's together, and then divide by 7 to get x alone. 3/7. The sequence stuff, sequences and series. So if we have the formula, the only number that shows up in these recursive formulas is r. R is the number. That's the thing that you multiply by every time to get from one number to the next. So if we start with 1, and then every time we multiply by 1/2, it says write out the next 3 terms. 1, 2, 3. So the next 3 terms, multiply by 1/2. 1 times 1/2 is 1/2. Multiply by 1/2 again. 1/2 times 1/2 is 1/4. Multiply by 1/2 again to get the next term. 1/4 times 1/2 is 1/8. There's your next 3 terms. Now we're going to do the same thing in reverse. This time write the formula. So that means we need to know what r is. We plug in r. Here's the formula. We plug in r times an minus 1. So to get from 1 to 4 to 16 to 64, what number are you multiplying by? That would be times 4. And then times 4, then times 4. So r is 4. There's your equation. So the initial population decreases by 9% per year. Write a function that gives the population after 2 years. So since it is decreasing at a rate of 9% per year, decrease means that our rate is going to be negative. That's all that means. So it's going to be a negative 9% or negative 0.09. So this is one of those parent equations. You have P, A, R, N, and T. Parent without the E. And there kind of is an E here. I'll explain a way to think about it. So it's the word parent. P is your initial population. So we're starting with 500. A is how much is left at the end, the amount at the end. That's what we don't know. That's X. R is negative 9%, so negative 0.09. Then it's a question. Is it E or N? If it tells you how often it's compounded, that would be more like money. It would be an N equals. This one doesn't tell you, so it's E. Just tells you you're doing the E formula. Tells you you're doing the E formula. So it's PE to the RT is the equation. So we're using E instead of N. And then T says for T years. So the quick one thing that you can do to check this out is to make sure that once you get an answer, you graph it. You can look at it. So here's it just asks to write the equation. So it's A equals P is 500, E, the rate, since it's decreasing, was negative 0.09, and then it said T years, so 0.09 T. There's your equation. You can type that into your calculator, and it should be decreasing. It should actually start out bigger and get smaller, kind of like that, which this graph will. If you have the graph and it's going up, that's not decreasing. So make sure that the graph is actually going down and to the right if you're able to check it with the